Hi there, this is Professor Eckhouse again for the second half of 5.2. These are just going to be some examples, a few really short ones and then a couple longer ones. All right, so find the bounds of integration A and B. That would be these right here for f of x, given what you're given going from 7 to 19 minus from 7 to 9. So give that a try. All right, so if you think about this on a number line, you're going from 7 to 19. So this is the x-axis, right? And we're going to take away from 7 to 9. Okay, so that means this portion is gone, and we're only going from here to get the area. So that means we're going from 9 to 19. So that means A would be 9 and B would be 19. Okay, let's try another one. Given that the integral from 1 to 5, in other words, the area under the curve of f of x from 1 to 5 is 58/13, what would it be if we went from 5 to 1? So pause the video, give that one a try. All right, hopefully you remember one of those properties was if you go in the opposite direction, you're just going to get the negative value. Okay, it's just going to be negative. All right, the next one, evaluate from 1 to 1 of that big, long, ugly thing. Pause the video and give it some thought. All right, hopefully you tried the question and you see that this goes from 1 to 1, which means it hasn't gone anywhere. It does not matter at all what any of this is. Doesn't matter. You're going from 1 to 1. So that means it is 0. And that's one of the properties. All right, next question. If from A to B equals -5 to 6 plus 6 to 7 minus -5 to 1, what are the bounds of integration for that first integral? In other words, what is A and B? So pause the video, draw a number line, see if you can figure it out. Okay, so hopefully you tried that. And in this one, we're going to go, we've got, let's see, we've got a -5, and we've got a 1, we've got a 6, and we've got a 7. So we've got -5 to 6, and then we're adding that to 6 to 7, and then we're subtracting from -5 to 1. We're subtracting that part. So that's going to go away. And all we're going to have left is from 1 to 7. So hopefully you see here that A is going to be 1 and B is going to be 7. So we go from 1 to 7 there, if you want to think of it that way. 1 to 7. All right. All right, a different kind of problem. We're going to start looking at some a little bit harder areas than I showed in the previous video. So again, this would have been the group work for you to figure out in groups, but I decided to go ahead and give a picture of this. So you need to know that x squared plus y squared equals r squared. So this right here is our r, right? So it's been rearranged to be y squared equals r squared minus x squared, and then to solve for y, we get r squared minus x squared. So you need to recognize this as a circle. That's really important that you recognize that. All right, so in this case, r is that 6. So I'm going to write that down, r equals 6. I'm going to tidy this up just a little bit. Okay, so we've got some space to write. All right, so this area is half of a circle. So it wouldn't be a function if I went on down around the whole thing. So for it to be a function, you only are talking about the top half. So the area of this thing is going to be half of the area of a circle. So that's half. What's the area of a circle? Hopefully you know that that is pi r squared. All right, so we've got 1/2 pi, or pi over 2, times r squared, that's 6 squared. So this is going to be 36 pi over 2, or 18 pi. 18 pi. You could also put that in your calculator and you would get about 56.55. So either one of those are good answers. Depends on what the question is asking for, an exact answer or decimals. All right, so how much of a circle do we use in this problem? All right, hopefully you said half a circle. All right, so next we're going to have a little bit more of a challenging problem. I'm going to have you guys pause and think about this question. All right, so how are we going to set this up? This is going to go from 0 up to 9. We have two shapes. What are they? So hopefully you see that we've got this shape over here, which is a triangle, and we've got, I need a much bigger highlighter for this one. There we go. There we go. So we've got two triangles. All right, so the problem is we don't know what their base is because we don't know exactly what this point is right here. So how are we going to find that point? And that would be the x-intercept, right? So we need to find the x-intercept of, so this is the absolute value equation, 7x minus 9. So if we just looked at the right green one, that would be this one. We could just set it up as 7x minus 9 equals 0. And that's going to be the same intercept as the other one, the other line, which together make up an absolute value equation. So we've got that x equals 9 over 7. So this value right here is 9/7. Okay, so that means that this distance here is 9/7, and this distance here would be what? Hopefully you notice that that goes to 9, and then we have to subtract 9/7, which would be 54/7. We like to use improper fractions when we do this stuff. So, all right, so now we need to do, let's find some areas. So we're going to find the area of the yellow triangle. So find the height. I'll just use, let me redo that because I'm going to use a little h. The height is going to be where x equals 0. It's going to be over right there. All right, so where x equals 0 is going to be y of 0, right, or f of 0. So that's going to be 7 times 0 plus 9, and that's going to equal -9 in absolute value signs, which is 9. Okay, so that height is going to be 9. So the area of this is going to be 1/2 times the base, which is 9/7, times the height, which is 9. We just found the height. And that's going to be 81/14. Right, so that's the area of the yellow. All right, the area of the blue. Go ahead and see if you can use a similar technique and figure that out. So we need to find h, where where x equals 9, right? So another way to write that is y of 9, however you want to write it. So we're going to have 7 times 9 plus 9, and that is going to be 54. Nope, not plus, sorry. Both of those should have been -9. I just noticed my mistake. So I apologize for that. So -9, we've got -9. Okay. All right, so the area is 1/2. 54/7 is the base, so 54/7, and the height is 54. And so I'm going to get 1,458/7. And now the total area is going to be the yellow plus the blue, and that is going to be the 81/4 plus the area of the blue, which was 1,458/7. And when you add those together, you get 2,997/14, which is approximately 214.07. Okay. Hopefully that helps you to understand areas and finding them with geometry and knowing that the area under a curve is going to be the integral. And soon we're going to do it without geometry. Thanks for watching.